Okay, we're going to talk about our new topic called like radicals. We're continuing on 4.2. So go ahead and pause the video and see if you can determine which which ones are what we call like radicals. And unpause when you think you're ready. Okay. So you might have said this one and this one and maybe this and this. Okay. Unfortunately, that is not correct. What we call like radicals are ones with the same index and the same radicand. Okay, index and radicand. So now that you know what they are, which one do you think they matches here? Okay, so if you see these numbers that are not in their prime, remember prime numbers are numbers that are only able to multiply itself and 1. So this one you have to do factor tree, 2 times 2 times 2. My index is 2. So I box 2, therefore my answer would be 2 square root of 2. Now which one is like a like term to this? Which one has the same index as this? Which one has the same index and same radicand? If you chose this one, then you are correct. So go ahead and try to factor tree these here. Put them in your notes if you need them to remember. Otherwise, here is how everyone is factored. Okay, so all the yellow, you can pause and just look, all the yellows go all with the yellows, the red with the reds, and so on. So I'm going to go ahead and erase my factored form or factored tree so it's easier to see which numbers are important. So if you want to go back and pause of what the factor trees look like, feel free to do that. So now let's try adding them, because in like radicals we can add them just like how we add variables. We know that x squared plus 2x plus 3x plus 4x squared, we know we add these two and these two together because of the exponent of the x's. So we do the same thing for radicals, except instead of just the exponents, we look at the index and the radicand. So if you look at the yellows, we have 3 square root of 2 plus 2 square root of 2 plus 3 square root of 2 plus 4 square root of 2 plus 2 square root of 2 plus 6 square root of 2. So pretend this is like 3x plus 2x plus 3x plus 4x plus 2x plus 6x. It acts the same way. Okay? So if we add all of them, we should get, so 3 plus 2 is 5, plus 3 is 8, plus 4 is 12, plus 2 is 14, plus 6 would be 20. So we would get 20 square root of 2. Okay, so there's 20 of square root of 2's. So that's how you would add them. So let's try the square root of 5's. Okay, adding and subtracting, it also applies to this. If we have parentheses, let's do square root of 5's. Let's do negative 5 square root of 5 plus 3 square root of 5. And then minus, I'm going to look at the reds. 3 square root of 3 plus square root of 3. Remember, when we have variables, let's pretend these are variables. Okay, I have to distinguish each one. Let's pretend that. So we know we have to distribute our negatives. So this becomes -5, or let's just bring that, -5 square root of 5 plus 3 square root of 5 minus 3 square root of 3 minus square root of 3. Remember, if it's just x, we always have a 1 in the front, so let's put a 1 here. So now we have -5 plus, so we only combine the like radicals. So instead of saying like term, we say like radicals. So these are like radicals here. So -5 plus 3 is -2 square root of 5. -3 minus 1 is -4 square root of 3. And so we leave it like this. You cannot add what's in the radical. You can only multiply what's in the radical, but you cannot add. So we're just saying there's -2 of square root of 5 and there's -4 of square root of 3. So that's how you add like radicals. Now let's see how we do with what we do when they are not in their reduced radical form. So here is one problem. You see how these numbers are pretty big, and I color-coded. These two are kind of like radicals because look at my index. But they're not entirely alike because they don't have the same index, or radicand. Same with these here. They just have the same index. So maybe they are the same radicand. So let's check. What we do is we just do factor trees. So we know this is 4 times 5, 2 times 2. My index is 2, so I'm going to box 2. And that's what comes out. So that's 2 square root of 5. Remember, this is my leftover. Let's do the 16. This is 4 times 4, 2 times 2, 2 times 2. That's 3 2's, because my index is 3, so I take out a 2, left over cube root of 2. Don't forget the index. Still minus, and then I'm going to go plus. Now let's factor 54. That is 6 times 9, 2 times 3, 3 times 3. My index is 3, so I'm going to box 3. And that's the one that goes outside. Cube root of 2. And now we bring this down because it's already at its simplest form. Here. So now it looks like we have the same indices, so that's a plural for index. And same here. Remember, if it's not there, it is automatically a 2. So now let's combine like radicals. So we just rewrite it so that they are next to each other. 2 square root of 5 minus square root of 5. This is -2 cube root of 2 plus 3 cube root of 2. Remember, there's a 1 in front if there's no number. So that's just 2 minus 1, which is just 1 square root of 5, minus 2 plus 3, which is positive 1, cube root of 2. So my answer is square root of 5 plus cube root of 2. If you want to leave your answer like this, it's okay with me. Okay, if you have any questions, please let me know.